this chapter of trigonometry completely like use the right angle triangle in all the possible ways, Hasni.
Okay.
Yes. So we already know that right angle triangle will have a 90° in it, inside it, and remaining two angles are acute angles. Acute means they will be 100% less than 90°, and all the three will be in between 0 to like more than 0, less than 90. Acute means.
Okay.
So those two angles sum and 190°. All the three together again will form 180, which they 100% satisfy the triangle sum rule. Angle sum rule.
Okay.
So we know that generally in a triangle, Hasni, the side that is opposite to the largest angle is the biggest side, Hasni, in the triangle. If you observe any triangle, it's a property of the triangle. Actually, you might have noticed or not. So because of that reason only, in the right angle triangle, hypotenuse is considered as the biggest side, Hasni.
Yes, sir.
Because the reason is inside the right angle triangle, we will not get an angle more than 90°. That is only with the higher, remaining two will be 100% in between 0° to 90°. That is less than 90, greater than 0. All together is 180, but 90° is only the biggest one.
Okay.
So because of that reason, the side opposite to 90°. Side opposite to 90° means how to check it, as we suppose there, let us take this figure. Side opposite, this is 90°. Opposite to 90° meaning is, Asmi, other than this angle is actually formed with this side and this side, no? Intersection
Yes,
of this horizontal and vertical sides, no?
Yes, sir.
So simply the place where this 90° is formed, leaving that vertex, leaving the sides of that vertex, that is BA and BC. If you leave those two, whatever the side that is left, that is called as opposite side of that vertex B has. Okay.
Okay. Okay,
So
sir.
AC is called as opposite side of vertex B. So similarly, can you tell what will be the opposite side of vertex A in this figure, Hasni? That is for this angle, what will be the opposite side? That is, if I take into consideration similarly.
BC.
Yes, Hasni. Suppose if I want to take opposite side of vertex C,
AB.
like that, Hasni. Okay, Hasni.
Okay.
Simply other
Okay.
leaving this letter, whatever letters involved side is it, that only. Like that also I can. Suppose A means leaving A, B, C. B means leaving A,
Okay.
B, A, like that. So actually,
Okay.
generally in a right angle triangle, 90°, this is only the largest angle. We don't have more than 90. Yes or no?
Yes, sir.
Because of that reason, Hasni, 90° opposite side, AC, is considered as a hypotenuse is the largest side of the right angle triangle. Why it's the largest side is it generally the triangle property itself, any triangle has to, not only this. You select a random triangle and if you know the sides of the triangle, okay, Hasri,
Okay.
the side that is opposite to bigger angle will be the biggest one, Hasri.
Okay.
And the side opposite to the smaller angle will be the smallest side. For sure, any triangle accept that rule. Will satisfy that rule.
Okay.
Yes, we. So now
Okay.
hypotenuse is the largest side of the right angle triangle because of also that reason only. Has to be 90° opposite side and more than 90° in a right angle triangle and will not be there. So okay.
Okay.
So now as per the right angle triangle, we know one rule called Pythagoras rule. Has to be Pythagoras rule is like we can tell that suppose if I consider the hypotenuse with letter H and the other two perpendicular sides as one as with A, D and another is with P has perpendicular. So P only
Okay.
has V has been before some time back.
So your voice is breaking. What could you repeat?
Yes, actually, some time back you said H square is equal to P square plus B square only has or V square used. We used V for P has or which letter for perpendicular?
B square plus P square, sir.
P
Base
only.
square plus perpendicular. Yes, sir.
Okay, actually. So let us take the 90° vertical side and the horizontal side as B and B, letter P, that is base and the perpendicular. The angle of intersection for those base and perpendicular is 90°. So this is a perpendicular on this base, actually. That is the meaning of that. Okay.
Okay.
So now, as per the Pythagoras rule, we know that side square plus side square is equal to hypotenuse square. What are those side square here? Base square and perpendicular square. B square plus C square is equal to H square. This anyways we will use it wherever we require us in the chapter. This is a basic Pythagoras rule which we already know previously also apart from trigonometry chapter. Yes or no, Asli?
Yes, sir.
Okay, Asli. Now we actually first exercise will have in total 6 trigonometric ratios. Asli. Ratio means we know that ratio means something when you compare two things, we'll call it as a ratio. With division, we'll call it as a ratio.
Yes, sir.
If you compare any two things with division operation, it is called as a ratio generally. Suppose you got 25 out of 25 and your friend got 20 marks. You're comparing both of your marks using a division operation, that is 25 to 20. That is called as a ratio. So here you're doing division action. 5 is a 5 wholes.
Yes,
Means
sir.
what? You got 5 times and suppose total 9 parts are there. You got 5 parts and your friend got 4 parts.
Yes, sir.
Like that. Means yes.
Okay, sir.
Means not like you're comparing, like you got 5, suppose for example proportionally if you go, it has been suppose out of 100 you get 100 out of 100. If you increase this 20 times, here also if you increase 20 times the person will get 80,
Okay.
right? So here the thing is Hasni, ratio is nothing but you are comparing two things with division operation. Okay, Hasni?
Okay, sir.
Okay, Hasni. So now Hasni, uh, then division operation how to compare? Suppose let us take a right angle triangle.
Okay.
Okay, Hasni?
Okay, sir.
So now Hasni, thing is asking now, let us take because difference in those two angles, if they're same means same marks we can keep as. Means both if I
Okay.
keep same means those two angles will be same. So I'll use different. So now ask me what I can understand is from the figure. So Hasni now let us just check the three sides Hasni and we'll take all the possible ratios. Okay, Hasni. Like I said,
Okay.
ratio means comparing two things by division operation, like 2 by 3, 3 by 2, like that. You're comparing
Yes,
2
sir.
and 3 with division operation. Now, what I will do is, Ashley, I'll write all the possible ratios here. We'll forget about the trigonometry, Ashley. What are the possible ratios I can write from the figure? You can see, Ashley, first I can write PQ by QR. Yes or no, Ashley?
Yes, sir.
And another one I can write QR by this only if I reverse it and write it as
Okay.
QR by
Okay, sir.
then. Like that, can you tell Ashley linking all the sides of the right angle triangle? Another I can take QR by
By RP,
yes, Ashley. And this reciprocal PR by
yes, I R.
okay, Ashley.
Okay. Okay, sir. Yes, sir.
Then after that, Ashley. One more possible is once try to think, Hasni, what is the other ratio which you can write? Is Hasni faster? Is Hasni? Hasni. One more is possible, Hasni. You can say I used these two sides
So
and
PR
then this
by QR.
used it. Now, see, once see, Hasni, I have used this side and this side. Then I used this side and this side. Leftover pair is
So once this show it again, I didn't get it.
first one I wrote PQ by QR, Hasni, and it's reciprocal. This pair, yes or no?
Yes, sir.
Then I have used QR with the PR, this pair, both reciprocal and that.
Okay.
Then one more pair is there. What is it, Hasni?
QR by PC.
Hasni?
So QR by PQ or PQ by QR? No, wait, done.
Yes, Hasni, I have used it last week. Simple, Hasni, I'm showing you. This by this I used it. Both reverse reciprocal and that. Then this and this, both pairs reciprocal and that. One more pair is left. Yes, Hasni. Fast, Hasni. It's easy to check, Hasni, actually. Just you're checking the pairs now.
Yes.
First, I checked the both horizontal and vertical sides. Then vertical with hypotenuse. What is the other leftover pair?
So first you check vertical.
First, I have used this pair, Hasni. Okay.
Yes, sir.
Then
Okay.
I have used this pair and this pair. Oh, sorry, the other two, blue color ones and yellow color ones. Now, one more pair is left.
Also, we didn't use horizontal by perpendicular, I mean hypotenuse, like so. Yes.
Yes, Hasni, that time.
So
So now
PQ by
can you
PR.
check? Yes, yes.
Hmm.
And it's reciprocal. PR by
PQ. Okay.
PQ. So these are the 6 different ratios which we can write, Hasni. Yes or no?
Yes, sir.
Okay, Hasni. I think there is no other possible pair to compare, Hasni.
No positive.
Yes, Hasni. So Hasni, now what we can tell is these 6, whatever ratios we wrote on the screen. Ratio is a form of comparison of two things using division operation. Okay, Hasni?
Okay. Okay.
These 6 things only we will call it as trigonometric ratios. Each of these will have a name, Hasni.
Okay.
So those we will discuss now, Hasni. All these 6, whatever ratios I wrote on the screen, these only will give certain name. We can see one if you write, the other will be just reciprocal of.
Okay.
Then this one more if you write, the other will be just reciprocal of. This one if you write, the other will be reciprocal of. So if you know 3 perfectly and you need to know the reciprocal names, reciprocals of those will be the other 3.
Okay.
Okay. But Hasni, before it took that much time, Hasni, you're fully confident here only, Hasni.
So
When
what
I'm
could you
right,
repeat? Your voice was breaking.
before you took that much time to tell these 2, Hasni, when I was writing these 4, you're fully concentrating here only, Hasni.
Yes, sir. In the middle, your voice got broke, so I got confused.
Oh, yes. So now how I have written all these 6 trigonometric ratios from the sides of the right angle triangle itself, have you understood it, Hasni?
Yes, sir.
Yes. These particular whatever I have written on the screen now, Hasni,
Yes, sir.
these will each of these ratios have their own name, Hasni.
Okay.
So that name now we will learn it. That is, these names depends on the angle which you take, Hasni.
Okay.
Because these trigonometric ratios will be writing for the angles other than the right angle. Other than the
Right
right
angle.
angle. This leaving this, suppose if I name vertex Q, no, this except for this vertex Q of this triangle, remaining 2 vertices I can write all the 6 trigonometric ratios.
Okay.
Means the meaning of that is sin P, there will be few trigonometric ratios for us, that is sine, full name, cosine, tangent, cosecant, secant, and cotangent. These are the full form of those trigonometric ratios. This we'll use it as most of the time first 3 letters for all of them. Sine,
Okay.
then cos, then tan,
Okay.
then cosecant. Because here first 5 will use, because cos only means both will mismatch now.
Yes, sir.
So because of that. So as we now, next one is as we see cot.
Okay.
Except for the fourth cosecant one, 5 letters. As the remaining all first 3 letters of the full names will use as.
Okay.
Any doubt has we?
No doubt, sir.
Okay. So now Hasni, what we will do is we will define the here. Suppose beside these angles can be changed, Hasni.
Okay.
For all of them, like A, and means whatever angle you are talking about, that particular angle, as per that angle, the value will change.
Okay.
But the common formula, based on that angle, from the triangle, we'll write the answer. But the common formula for sine, whatever angle we are talking, we are taking into consideration also, the common formula is sine formula is what has me?
So what could you repeat? Side?
Opposite side by hypotenuse. Okay. So finally, if I remove these and if I write hastily, sine of angle is opposite side by,
Hypotenuse.
suppose whatever angle here will be there hastily. Let us name this as theta. Okay. Opposite side by opposite by opposite means simply opposite side has by hypotenuse, which
Okay.
also called as, like, say that for opposite side generally for this, why we will tell like this is actually perpendicular depends on the position actually. Like for example, according to you actually, let us take if this is a has. So 5
Okay.
or 10. Can you tell sine A Hasni for this figure? With your knowledge, sine A is equal to
AB by BC, which is x by 5.
Hasni formula for sine is?
Before that, we have to use Pythagoras theorem, right, sir, to find it.
No, Hasni. That is correct only. But what is the sine formula?
Opposite by hypotenuse or perpendicular by base. Perpendicular by hypotenuse.
Yes, Hasni. So hypotenuse is which one, Hasni, here?
Okay. 10, sir.
So now according to you, opposite side is what, Hasni, for this A,
5.
angle A? Yes,
5, sir.
Hasni. So here your teachers called this also as perpendicular by hypotenuse only, Hasni, in this case also.
Yes, sir.
Then here you can see actually perpendicular position changes. As per this vertex A, this BA will become the base then.
Yes.
This will become the perpendicular in that way.
Okay.
Or
Okay.
opposite side will say. This will, for that angle, this will become opposite side. Before I was telling opposite side means how to check it first.
Okay.
For that angle A, opposite side.
Okay.
Any doubt, Hasti?
No doubt.
Yes. So now we can tell the formulas in the following. Sine formula is like opposite by hypotenuse, or whatever angle here has. For that, this angle position wherever it is, for that angle opposite by hypotenuse. So,
Okay.
or we can call it as perpendicular by hypotenuse.
Hypotenuse. Okay.
Then cos, for that wherever the angle is at that particular angle, adjacent side by hypotenuse.
Hypotenuse.
Adjacent side is nothing but, for example, theta is this actually. Whatever the side that is in contact with that other than the hypotenuse, that will become the adjacent side for that theta.
Okay.
Then tan has to be sin theta by,
Cos theta.
so which is
Is it opposite by adjacent?
is has correct. So another form, if we divide these two has to, hypotenuse will get cut and finally we'll get opposite by adjacent has.
Okay.
Or another way we can tell perpendicular by perpendicular by
Base.
hmm. Any doubt, Hasni?
No doubt, sir.
Okay. So now, Hasni, the remaining three are just reciprocal of these, Hasni. Reciprocal for these
Okay.
remaining three. So we'll call the, like I said, sin theta reciprocal is cosecant theta.
Cosec. Okay.
Cosec, we can call cosec theta, which is full name is cosecant theta. Like that.
Okay.
So its formula will become hypotenuse, just reciprocal of sine. Hypotenuse by opposite, or 1 by sine theta,
Okay.
or one more is hypotenuse by perpendicular.
Perpendicular. Okay.
Now similarly, Hasni, secant theta. Secant theta is equal.
Okay.
What are the formulas, Hasni? Reciprocal of cos, Hasni.
Okay.
Hypotenuse by adjacent.
Adjacent.
Another is 1 by cos. And one more is hypotenuse by base.
Okay.
These are the ways we can tell.
Okay.
And finally, cot, Hasni. Cot theta is equal to adjacent side by opposite side.
Okay.
Adjacent by opposite, which is equal to 1 by tan theta.
Okay.
And finally, one more is Hasni. One more is, can you tell Hasni what is another way? Base by
Okay.
base by
Base by perpendicular.
yes, Hasni, because tan theta is perpendicular by base, no? So this will
Yes,
become
sir.
cot theta will become base by perpendicular, or adjacent side by opposite side, or 1 by tan. Like
Okay.
all these possible ways we'll use it as
Okay.
deal of the sums. In the last exercise, especially if required cot theta, the last exercise sums when we are doing, no, instead of writing tan theta as cot theta as adjacent by opposite side, we'll write 1 by tan theta.
Okay.
Similarly, sin theta is 1 by cosecant theta in the last exercise. So cosecant theta is called 1 by sin theta, like that. Instead of writing opposite by hypotenuse or hypotenuse by opposite, like that. For cosecant opposite, instead of writing hypotenuse by opposite, we'll write 1 by sin theta, like that. Similarly, sin theta, instead of writing opposite by hypotenuse, we'll use 1 by cosecant theta.
Okay.
So, Hasni, I'm deleting this. Once can you tell orally all the 6 trigonometric ratios formulas, Hasni? First, start with sine, Hasni, and then reciprocal of it, then cos, reciprocal of that, then tan, reciprocal of that.
Okay. Sir, could I use perpendicular by base instead of like opposite by adjacent like that?
Ah, yes, Hasni.
Okay, so sine is equals to perpendicular by hypotenuse,
Yes, Hasni.
and cosec is opposite, which is hypotenuse by perpendicular,
Yes, Hasni.
and cos is uh, base by hypotenuse, and its opposite, and 1 by cos is secant, which is hypotenuse by base,
Okay, Hasni.
and tan is perpendicular by base. So cot is base by perpendicular.
Tan is perpendicular and cot is base by perpendicular. Yes, Hasni.
Yes.
So, So Hasni, once you tell that way, also Hasni, by imagining out opposite by adjacent like that also.
So once we repeat,
Once you imagine it and tell in that opposite by adjacent by opposite like that also.
this one also. Sine is opposite by hypotenuse.
Yes,
So
Hasni.
cosec is hypotenuse by opposite.
Yes.
Cos is uh, adjacent by hypotenuse. So
Yes.
secant is hypotenuse by adjacent,
Yes.
and tan is opposite by adjacent. So cot is adjacent by opposite.
So Hasni, now next part is Hasni. Like I said, I was telling before, one point. As per the position of the angle, these sides opposite or adjacent will vary as per the position of the angle.
Yes, sir.
So for which angle you are writing, as per that angle, we have to take the base of perpendicular in that way or adjacent or opposite, whatever. Okay, Hasni?
Okay, sir.
So let us take, for example, we will write all the positive trigonometric ratios for this figure, Hasni. So I'm not marking any of the angles like theta, alpha, gamma like that, Hasni. Okay, Hasni? Directly for original vertices A, B, C only will write. A and C only will write. Anyways, we cannot write the trigonometric ratios for vertex B, Hasni, 90°.
Okay.
So now we will write for first for all the trigonometric ratios, we'll write for angle A, Hasni. So can you tell Hasni, sine A will become how much now? As per angle A, the opposite side will be, this is the angle now, Hasni. The
Yes,
opposite
sir.
side will become the side that is not at all involved with vertex A, Hasni. So opposite side will become which one, Hasni?
BC.
Yes, Hasni. So
So
BC
BC by
is formed
AC,
by
sir.
opposite by hypotenuse or perpendicular by base. Perpendicular by base. As per that, what angle A, Hasni, BC will become the
Sir, isn't
opposite side
sine
of the.
perpendicular? Sir, isn't sine perpendicular by hypotenuse?
Oh, yes, Hasni. Perpendicular by hypotenuse. As per this angle, perpendicular or opposite side will be BC, Hasni, and hypotenuse
BC
is
by AC.
Hasni. Then cosecant A reciprocal of it, Hasni, hypotenuse by opposite, which is
Opposite.
hypotenuse by perpendicular as per that angle. So which will become
So
simply
AC.
reciprocal of AC by BC. No, Hasni.
BC. Yes, sir.
Sin A cosecant A, then tan A. Hasni. Tan A is what, Hasni?
Tan A is perpendicular by base or opposite
Yes,
by adjacent.
yes.
So BC by AB. BC by AB.
Yes, Hasni, that is correct.
So cot will be AB by BC, sir.
Adjacent by opposite and base by perpendicular. AB by BC. No, Hasni.
Yes, sir.
Any doubt, Hasni?
No doubt, sir.
Okay, Hasni. Now finally left. Actually, I should write first cos, but I wrote this as not a problem. Cos A is equal to adjacent by
Hypotenuse. AB by AC, sir.
base by hypotenuse. Exactly. And reciprocal of that is secant A, which is hypotenuse by adjacent. Yes, Hasmi?
Yes, sir. So AC by AB.
X by B. Now we will write for angle C, Hasmi. Okay.
Okay. Okay, sir.
Angle C. Sin C will become what, Hasmi? Sin C is equal to opposite by
Hypotenuse.
hypotenuse. The formula remains same, but as per the vertex C, we should select Hasmi.
Yes, sir.
So what will be the answer, Hasmi?
AB by AC.
AB by AC, correct. For that vertex C, Hasmi, opposite side of the perpendicular will become AB. Yes, Hasmi. Now, similarly, cosecant C.
AC by AB.
So the formula is hypotenuse by
By
opposite or
opposite.
hypotenuse by perpendicular, which is
AC
AC
by
by
AB.
correct,
AB.
Hasmi. Now, tan Hasmi, tan C.
Tan C, sir.
Yes, Hasmi.
AB by BC.
AB by BC. Hasmi.
Yes, sir. So cot is BC by AB.
Actually, tan C means AB by BC, which means actually we can tell perpendicular by
Base.
base. So it will become AB by BC now, Hasmi.
Yes, sir.
So cot C will become
Base by perpendicular BC by AB.
oh, I forgot to write one other formula. Okay, 2 times I wrote that. So tan C is equal to Hasmi hypotenuse by yes, Hasmi tan formula is perpendicular by base no,
Base. Okay, okay.
opposite side by adjacent side.
Yes, sir.
That is perpendicular by base, which is
AB by
AB by
BC.
BC.
So cot will be adjacent by opposite, which is equals to B by C, which is equals to BC by AB.
Yes. And finally, cos C Hasmi, which is adjacent by hypotenuse, which is or base by hypotenuse. Okay, Hasmi,
Okay.
which is equal
So
to
BC by AC.
BC by
AC. ABC. BC by AC, sir.
yes, Hasmi. Correct. Then secant C Hasmi.
So
Hypotenuse by
hypotenuse by adjacent, which is equals to H by B, which is equals to AC by BC.
yes, hypotenuse by base. That is Hasmi. And so final formula is Hasmi.
So could you repeat?
Yes, Hasni. Final formula is Hasni, hypotenuse by adjacent. It's called
It is
h by
AC by BC. Yes, AC by BC.
AC by BC. No, Hasni?
Yes, sir.
Okay, Hasni, nice, Hasni. So these are all the way. So Hasni, in this figure, suppose if instead of vertex A and vertex C, we wrote it for vertex A and vertex C now. Hasni.
Yes, sir.
Instead of if they mention any theta, like at that positions, Hasni, if they mention any angle as theta and this angle as beta or alpha, as per that, if they say sine beta or sine A, both sine theta or sine beta. Sine theta means sine A only.
Okay.
So if they particularly mention these here means we will take directly sine theta, sine beta like that. If they
Okay.
don't mention anything means whatever vertex is there, that only will take us sine A, sine C like
Okay, sir.
that. So Hasni, I think you have understood all the six trigonometric ratios how we are writing now, Hasni, based on the angle.
Yes, sir.
Other than 90-degree vertex, Hasni, remaining two vertices, for those remaining two angles, we can write all the six trigonometric ratios, Hasni.
Okay.
So the side adjacent side, opposite side will vary as per the angle position other than the 90-degree one which you are taking into consideration.
Okay.
Yes, Hasni. So Hasni will directly finish the example sums and exercise sums of first exercise in our tomorrow in our next class. Hasni.
Okay, sir.
Hasni. Okay, Hasni. Bye, Hasni.
Bye, sir.